You're given a linked list and a number k. Reverse the nodes in chunks of k, all the way down the list. With 1, 2, 3, 4, 5 and k equal to 2, the answer is 2, 1, 4, 3, 5. Pairs flipped in place. Here's the list. 5 nodes, each pointing to the next. The last one points to nothing. K is 2. We take the first 2 nodes and reverse them, then the next 2, and so on. One important rule. We don't change the values. We rewire the actual nodes, the pointers themselves. And if the tail has fewer than k nodes left, it stays as it is. No partial reversals. The obvious move. Reverse each group of 2 by flipping the pointers as you go. Flip the first pair. Node 2 now points to node 1. So far so good. But node 1 used to point to node 3. We just overwrote that link. Now node 1 points back at 2, and nothing reaches node 3. The rest of the list is lost. Reversing a group is easy. The hard part is stitching the groups back together afterward. So before we touch anything, we need to remember the node before the group and the node after it. Start with a trick that removes a special case. Put a fake node in front of the list. This dummy node is just a placeholder. Now the first real node has something in front of it, like every other node. A linked list is a treasure hunt. Each node holds one clue pointing to the next. To reverse, we flip every clue to point backward. Keep a pointer called group prev. It sits on the node right before the group we're about to reverse. Before reversing, walk k steps forward to find the kth node. That node is the last one in the group. If walking k steps runs off the end, fewer than k nodes remain. Leave them and return the answer. Also remember the node just past the kth. Call it group next. That's where the reversal stops. Now reverse the group with the standard flip, but seed it carefully. The group's tail must end up pointing at group next. You might be tempted to seed the reversal with nothing, pointing the tail at null. That snaps the list in half. After reversing, 2 rewires. Group prev points to the new head, the kth node. Then the old head becomes the next group prev. Trace it. Dummy in front, group prev on the dummy, k is 2. Walk 2 steps from group prev. Step 1 lands on node 1. Step 2 lands on node 2. Kth is node 2. Group next is whatever follows it, node 3. Set up the reversal. Prev starts at group next, node 3. Current starts at the group head, node 1. Current is node 1, not yet at group next. Save its next, node 2. Point node 1's arrow at prev, node 3. Move prev to node 1, current to node 2. Current is node 2, still not group next. Save its next, node 3. Point node 2 at prev, node 1. Move prev to node 2, current to node 3. Current is now node 3, which equals group next. Stop. The group is reversed. 2 then 1. Reconnect. The old head was node 1, now the group's tail. Save it as the next group prev. Group prev, the dummy, now points to the new head, node 2. Advance group prev to the old head, node 1. The list now reads 2, 1, then 3 onward. Second group. From group prev at node 1, walk 2 steps, node 3, then node 4. Kth is node 4, group next is node 5. Prev starts at node 5, current at node 3, the group head. Save node 3's next, node 4. Point node 3 at 5, prev to 3, current to 4. Save node 4's next, node 5. Point node 4 at 3, prev to 4, current to 5. Current is node 5, which equals group next. Stop. The group is now 4 then 3. Reconnect. Old head node 3 becomes the next group prev. Group prev, node 1, points to node 4. Advance group prev to node 3. The list reads 2, 1, 4, 3, 5. Third group. From node 3, walk 2 steps. Step 1 is node 5. Step 2 runs off the end. Fewer than 2 nodes remain. Stop and return the list after the dummy. The answer is 2, 1, 4, 3, 5. Node 5 stayed exactly where it was. Second example, same list but k is 3 now. Groups of 3. Group prev on the dummy. Walk 3 steps. Node 1, node 2, node 3. kth is node 3, group next is node 4. Prev at node 4, current at node 1. This time we flip 3 nodes. Save node 1's next, point node 1 at 4, prev to 1, current to 2. Save node 2's next, point node 2 at 1, prev to 2, current to 3. Save node 3's next, point node 3 at 2, prev to 3, current to 4. Current is node 4, which equals group next. Stop. The group is 3, 2, 1. Reconnect. Dummy points to node 3, the new head. Group prev advances to old head node 1. Second group. From node 1, walk 3 steps. Node 4, node 5, then off the end. Only 2 nodes left, fewer than 3. Stop. Leave 4 and 5 untouched. Return the list after the dummy, 3, 2, 1, 4, 5. Notice the leftover pair kept its original order. That's the partial group rule doing its job. Notice what happened. Every node had its pointer flipped exactly once, and we walked each node a fixed number of times. Nothing got reprocessed. We touch each node a constant number of times, so the running time grows in step with the list length. We only keep a handful of pointers, no matter how long the list. The extra memory stays constant. Remember the dummy node. It gives the first group a node in front, so reconnection works the same everywhere. Remember the check, walk k steps first. If you run off the end, return without reversing that group. Watch the reversal seed. Prev must start at group next, not at nothing, or the tail points nowhere. Watch the reconnect order. Save the old head before overwriting group prev's pointer, or you lose the rest of the list. Now the code, it mirrors the trace step for step. Build the dummy node in front of the head, and start group prev sitting on it. Each round, walk k steps to find the kth node. If a step hits nothing, return everything after the dummy. Grab group next, the node just past the kth. That's the boundary the reversal stops at. Seed prev at group next, then flip pointers until current reaches group next. Standard reversal, bounded to one group. Finally, save the old head, point group prev at the new head, and move group prev forward for the next round. The pattern here is bookkeeping. Track the boundaries before you cut, and reconnecting becomes mechanical. You'll reuse this on any in-place list surgery.